Okay, in this video we're going to look at a concept called resistivity. Resistivity is kind of a catch-on from resistance, and we're going to look a little bit at where it comes from, defining it, the equation, very quick video, and then we'll get to using it over the next couple of lessons and do some practicals on it. So what we've got here, we've got a situation where we need to define something more intrinsically than just saying resistance. Because as you may or may not be aware, the more, for example, wire you have, the more resistance you have because it's longer. So we need a property of a material that allows us to say, oh, well, this is more resistive or less resistive than another material, and that's where resistivity comes in. So we start out with the idea of resistance, and we've already suggested that the longer the material, or the longer a wire, the greater the resistance. And actually what we would observe is that the resistance is directly proportional to the length of that material. Now there's also another property that would have an effect on resistance. And this is nice and easy to explain really, because if you think about it, if I walk down a very tight path with lots of people on it, and I walk down a big city main street with the same amount of people on it, which one's easier to walk down? Well, clearly the one that's a big main street with the same amount of people, I've got more space. And so the idea here is that the greater the cross-sectional area of a material, the lower the resistance. And as a result, what we expect to see is that resistance is inversely proportional to the cross-sectional area. And believe it or not, we could put these two concepts together, these two relationships together into one full equation, and that comes together with a constant. So R is going to be equal to rho L over N. So we can see here that resistance is directly proportional to the length, but inversely proportional to the cross-sectional area. So here enters this constant of proportionality. That is resistivity. Now you might be thinking, oh, wait a minute, rho, slanty p, yeah, we're using it for something else. We're going to use it for resistivity in this case. So, something to watch out for. It's been used for momentum, it's been used for density, and now we're using it for resistivity, and obviously not to confuse it with the normal non-slanty P of pressure. Okay, so this is a nice equation. You'll find this in your data sheet, but you do need to know all of these different terms and whatnot there. So what's the units of resistivity? So first of all, we need to rearrange this equation. So we can rearrange this by, so if we times both sides by A, that leads us to RA is equal to rho L. And if we then divide both sides by L, we get RA over L equals the resistivity. Now the nice thing about that, I'm just going to write it the other way around because I like to write left to right, not right to left. So resistivity is RA over L. And if we look at the units of that, resistance is ohms, cross-sectional area is meters squared, and the length is in meters. What you'll hopefully see here is that we can cancel the two, cancel the m at the bottom, and that leaves us with a final unit of resistivity of the ohm meter. That's not ohms per meter, it's the ohm meters. And that is the intrinsic property of a material. Resistivity, if I quote the resistivity of a material, no matter how much of that material I have, it has always got the same resistivity. It might have a different resistance than a smaller amount of that material, however you're going to shape it or mold it, because obviously the length and the cross-sectional area have opposite effects. So, but however, no matter what shape of material you have, or how much of it you have, you always have the same resistivity. And so, how do we define resistivity? Well, unfortunately, there's no quick and easy way of defining it. Quite simply, the way you would define this in an exam is by saying, well, the resistivity is equal to the resistance, the product of the resistance times by the cross-sectional area divided by the length of the material that is being used. So resistivity is the product of the resistance times the cross-sectional area divided by the length. Quite simply, what you could do is you could just write that down and then define the terms. And you would get all required marks for defining what resistivity is. Okay, so a nice simple short video there. We're going to put this equation into use. We're hopefully going to prove some of these relationships I've shown you, and we'll get to set to work in using it in different cases and certain areas.